Hi, I'm Jeff Wimmett, and I'm an applications engineer here at Altera. If you're designing low-power, FPGA-based applications, you should keep watching to learn about how the design examples that we include in Altera's development kits can fast-track your FPGA design. In this video, we'll look at the Cyclone 3 LS FPGA development kit. Now, this kit is a complete design environment that provides an unprecedented combination of low power, high functionality, and design security. Now, the kit is based on the largest density, low power FPGA that's currently shipping. That's our Cyclone 3 LS EP3 CLS 200 FPGA. And I'm going to show you two designs that ship with all of our latest development kits, the board test system and the board update portal. Now, these designs allow you to verify board functionality, easily access all the latest documentation and design examples, and even update the board itself with a new FPGA design. We provide all the source code for both these designs, so that'll be installed when you install the kit, and it makes for an excellent starting point for your own design. Let's get started. Now, we'll begin with the kit's board test system, or BTS as we call it. We can use the BTS interface to determine whether our board is working properly. Let's launch the exe file to open the BTS on our laptop. You can see each tab here in the GUI corresponds to one or more of the board's components. The config, Gpio, and SRAM and flash tabs allow us to interface to those components. On the config menu here, we have information about the page select register. We also can set the programmable oscillator to whatever frequency we like. Then we have some information about the JTAG chain, as well as some board information, the MAX2 code revision, and the MAC address of our board. And then finally you can see the flash memory map here. If we move to the GPIO tab, I'll select it here. On this tab we can choose to write some text to the LCD, so I'll type some text here. Cyclone 3 LS has no errata. And then I push the right button, and you can see that text comes up here on the board's LCD. We can also light some LEDs, so if I click on an LED here that's lit, it'll unlight on the board there. And you can also note the position of dip switches here, and you can detect whether a push button switch is depressed. Next tab we'll look at is the SRAM and flash tab. We'll click on that, and here you can read or write to the external SRAM or flash memory devices that are on your board. Now we'll activate the tab for Ddr2. Now, to do this, we have to reconfigure the FPGA with a new design. We can do that simply by selecting the Configure menu and then Configure with Ddr2 Design. So we'll select that, and then we push the Configure button here. And now the FPGA is being configured with our Ddr2 design, and we're downloading. Now the Ddr2 tab has become active. Now there are two different Ddr2 devices on this board. I can select the one that's on bank 7 or the one that's on bank 8 of the FPGA to be the one that we'll test. Bank 7 is fine, so if I just push the start button here, you can see these bar graphs track the throughput. You can change the number of addresses to write or to read by using the slider bar, and you can inject errors or change the data type, or change whether we're write reading, reading only, or writing only. Now you can find more information on these designs in the Help menu. If I select that here, you can see this has more information about how these designs are actually put together. Now in order to activate the last tab, the HSMC tab here, I would follow the same steps we went through to activate the Ddr2 tab. And remember, all the source code for each one of these designs is available to you and provides an excellent starting point for creating your own design. Another useful tool here is the power monitor. The power monitor displays the current and power being consumed by each voltage rail. To access the power monitor, we can hit the button in the upper left corner of the BTS interface, or you can access it from the Start menu. I'll hit the button here, and that'll bring up the power monitor. Now you can see that you can look at any one of the voltage rails. I'll choose VCC int here, and so we can select the power rail, and then we can scale a little bit so that we can see it better. We'll scale up to 600 milliwatts, and there you can see a graph of the power being consumed. And remember, the power monitor circuitry here is independent of the FPGA design itself. In other words, you can configure the FPGA with any design you like without having to add any power monitor specific code, and the power monitor will still function. Next, let's go over the board update portal. Now, the board update portal design example includes a Nios 2 32-bit embedded processor along with an Ethernet MAC. And this design serves a web page from the flash memory on your board. That web page allows you to have a look at some of the board features, it links to important information, and it allows you to write a new design to the user portion of the flash memory on your board. Now, the source for this design is also installed with your development kit. And this design is actually preloaded into the factory portion of the flash memory on your board. So when you power up the board, that design is going to be loaded from the flash memory into the FPGA. When that happens, your LCD display will read connecting. Now, when your board is connected to a DHCP-enabled network, the Nios 2 processor obtains an IP address and displays it on the LCD. And that's how you access the board update portal web page. You just type that IP address into the address bar of your web browser. I'll do that now. So my LCD says 137.57.233.133. There are three primary things you can do with this board update portal web page. You can mouse over the board photo here to have a look at some of the board features. So for instance, here's the memory devices and the configuration, status, and setup elements. Now if we look up on the top right here, we'll see some links to useful design resources on Altera.com. The development kit product homepage is the top one here, and that may be the most important one. That's where you're going to find all the updated design examples and documentation for your board. And finally, you can use this board update portal to write a new design into the user portion of flash memory on your board. All you need to do is download the .flash file to your hard drive, or you can create one as is documented in the kit's user guide. Now I have one that I call the Knight Rider design. I'll navigate to it by pushing the Browse button here, and then selecting the .flash file. Then I'll push the Open button. And you can see I've now got that design selected here. Now I don't have a software element to this design, so all I need to do is push the Upload button. And now that design is being written to flash. We can watch the progress bar there, and when that reaches 100%, we'll know the design has been successfully written to flash. And as we get to 100% here, you can see now the upload is complete, and that design has actually been written to the user portion of flash on our board. Now we push the select configuration so that the user portion is selected, and then we'll push the reconfigure FPGA push button, and there you can see why I call this the Knight Rider design. Now that you've seen some of the capabilities of our development kits, we hope you're ready to try one out. All of our latest kits and the designs that come with them provide you with an excellent way to prototype and develop your own system. The Cyclone 3 LS FPGAs give you a suite of security features at the silicon, software, and IP levels, all on a low-power, high-functionality FPGA. It's just what you need to protect your design from tampering, reverse engineering, and cloning. As far as the kit goes, you can use it to develop and test designs that take advantage of the security features in that Cyclone 3 LS FPGA. And with the HSMC connectors on this board, you can interface to any one of over 24 different HSMCs that will allow you to expand the board's capabilities. Now, the kit ships with Development Kit Edition of Quartus 2, which basically gives you a 1-year license. And with that, you'll have all the resources you need to prototype and test your design.